Hello everyone, myself Sai Prasad, a lecturer in AhleBait High School and Junior College. Welcome to a series of the lectures of Intermediate First Year Maths A. We have started a discussion with the different chapters starting from functions, mathematical induction, right? And then we did a few problems of 1A, right? Today we are going to start a new chapter, that is addition of vectors. What is this? What is this addition? What is this vectors? Shall we start? Before going into the chapter, I think you have a basic introduction about what is a scalar and what is a vector. Isn't it? Just tell me what is a scalar. A scalar is a physical quantity which has only magnitude. That's the basic definition you would have studied in your physics, right? Then what is a vector? A vector is a physical quantity with magnitude and also a direction. Clear? That is, for example, if I want to specify that the distance from point A to B is 5 centimeters, okay, then this is a magnitude. Okay, am I specifying any kind of direction? No, right? If I specify it as AB is equal to 5 centimeter, what does this mean? It clearly tells that it is the displacement, or else it can be called as a magnitude with direction. Clear? So this can be called as an vector. Clear? As of now, our definition becomes like a vector is a quantity, or else simply it is a line segment with direction. Clear? Or simply a vector is nothing but a directed line segment. That is not a ray or not a straight line. Right? Straight line, how it will be? It is directed towards infinity. Yes or no? It doesn't have any fixed length. It starts from infinity, it goes up to infinity. Clear? That is a straight line. What is a line segment? It has a fixed 2 points. Okay? But our vector is a directed line segment. Clear? Fine. Then how do we represent a vector? A vector is always represented in the direction of our coordinate system. That is, for example, in our 2D systems we have two axes. One is x, one is y. Then it has two unit vectors along x and y. That is, along this is I, along this is j. What are those all? Again we will discuss what are unit vectors and everything. But in a standard, our vector is always represented as some xi plus yj bar, where what is this? It clearly tells that it is a plane. Along x-axis it is at a distance of x, along y-axis it is at a distance of y. Clear? This is a vector. Fine. We are going to represent a vector always under this bar. Okay? In your textbooks they may represent it in the dark font if you observe. Is it clear? That is, you will get a bold font. Clear? Fine. This is a basic broad introduction about what is a vector and everything. Shall we start discussing what are different types of vectors? Fine. Before going to the different types of vector, you have to remember vector has a direction as well as magnitude. Okay, what is this magnitude? The magnitude of any vector is given as under root of I component plus j component. What if it is a 3D coordinate? Tell me. We'll have some third term. Is it clear? Fine. Always a vector magnitude is represented under this modulus. Clear? Fine. Is it okay? Next, what are the different types of vectors? Tell me. The different types of vectors are simple. First of all, you have to remember what is position vector. Next, what is null vector, unit vector, and so we'll discuss. Clear? Now tell me, what is a position vector? Position vector is a vector which gives the position of that particular point. For example, if I say there is a point P with coordinates x, y, z, okay, and from origin what will be its distance? It will be OP. It is 0, 0, 0. Okay, therefore the vector OP is given by x minus 0 into I, y minus 0 into j plus z minus 0 into k. Therefore it gives us xi plus yj plus zk. This is OP. This is a position vector formula. A position vector gives the position of a particular point from origin. Is that clear? Even I can write any term, that is OA, OB, OC, like that. That is a position vector. The next is null vector and unit vector. Null means 0. That is a vector whose magnitude is 0. That's it. A unit vector is a vector whose magnitude is 1. Okay, it is simple to remember. In some cases, unit vector is represented by cap. It clearly indicates that that is a unit vector and its magnitude is 1. Okay. Next, how do we find a unit vector? Is nothing but the vector by its magnitude. That is a formula of a unit vector. Just you remember. Is it clear? Fine. These are the basic things, and few more things we can discuss, such as addition, multiplication. For example, if A is given like this, what about some parameter S into A? Then it will be Sxi, Syj plus Szk. That is nothing but we can multiply that S to all the terms. How do we add? That is the main thing. What is addition? In addition, we do only like terms. That is, we can add I terms, j terms, k terms separately. Clear? That is a basic thing. And there are a few definitions you can remember as coplanar. Coplanar. What do you mean by collinear? Collinear is they lie on same plane. Okay, that is same line. Coplanar means they lie on a same plane. Okay. Why are we discussing only about plane? Because in a vector is always, it might be 2D or it might be 3D also. Okay. That's why we are discussing it as a coplanar, that is all lie in a same plane. Clear? Fine. And when it comes to addition, there are two rules you have to remember. That is triangle law and one is parallelogram law. What is this? Is if there are two vectors A bar and B bar, then the third vector C bar is given as A bar plus B bar. Clear? For example, once again let me tell, there are two vectors along two adjacent sides of a triangle. Then the sum of the two vectors is nothing but a third side. Okay. Next, when it comes to parallelogram, two vectors are represented by two adjacent sides, A bar and B bar. Okay, for example like this. This is B bar, this is A bar. Then the diagonal represents C bar, which is equal to A bar plus B bar. Clear? You do understand? Fine. These are the basics of addition of vectors. Shall we start doing problems of this? Let's do. Look at these questions here. He is asking if A is equal to I bar plus 2j bar plus 3k bar. Just I will simply call it as I plus 2j plus 3k, and B bar is equal to 3i plus j. Then he is asking us to find a unit vector in the direction of A plus B. How do we find? What is the formula of unit vector? I told vector by modulus of that vector. So first let us add these two vectors, I plus 2j plus 3k plus 3i plus j. I plus 3i is 4i, 2j plus 1j is 3j and 3k. Okay. Now what is the magnitude of this A bar plus B bar? That is 4 square plus 3 square plus 3 square. That is 16 plus 9 plus 9. Okay. How much is it? 16 plus 9 is 25, 25 plus 9 is 34. So unit vector along A plus B is, what is it? 4i plus 3j plus 3k by under root 34. Okay, is there anything extra to remember? No, right? We just found out the unit vector. Clear? Next, if this vector and this vector are collinear vectors, then he is asking us to find the value of lambda. How do we find? First, let us write, let A is equal to minus 3i plus 4j plus lambda k. Okay, and the next, B is equal to mu I plus 8j plus 6k. Then what do you mean by the term collinear? Collinear means one vector lie on another vector, which means it can be in the multiples. That is nothing but I can directly write A is equal to some constant, let us say t, b bar. Okay, collinear means all lie on the same line. Since they are already lines, one can be a multiple of another. Okay, now see here, that is minus 3i plus 4j plus lambda k is equal to t into mu I 8j plus 6k. Before finding the values of lambda and mu, I have to find the value of t. Okay, check in which number t doesn't lie. J coordinates. Okay, that is here j coordinate is 4 and here j coordinate is 8t. Let us substitute it. From this I will get t as 1 by 2. Okay, next here let us take I coordinate. Minus 3 is equal to t mu. Minus 3 is equal to what is t? 1 by 2 into mu. Therefore mu is equal to minus 6. Clear? Next, lambda value. Here lambda is equal to 60. What is lambda? 6 into t is 1 by 2. 1 by 2. 2 ones are 2 3s are. Therefore lambda is 3. Clear? Is it easy to solve? Shall we go to the next problem? Let's do. Look at these questions here. He gave, if the position vectors of the points A, B, C are these 4 vectors, then he's telling that AB equal to lambda is, and he's asking us to find the value of lambda. Okay, now see here, how do we get A's? The position vector of A, that is OA, is equal to minus 2i plus j minus k. Okay, the next OB is minus 4i plus 2j plus 2k, and the next OC 6i minus 3j minus 13k. Okay, now I have to find the value of AB. How do I find AB? Tell me. Just have a look. OA is a position vector, OB is a position vector. Then what is AB? OB minus OA. Remember that from now. AB is OB minus OA. Okay, that is minus 4i minus into minus plus 2i, that is minus 2i. 2j minus j, 2k minus into minus plus k, it is 3k. Next, AC will be obviously OC minus OA. Okay, 6 minus into minus plus 2 is 8i, minus 3j minus j, that is minus 4j, minus 13k minus to minus plus k, that is plus 12k. Okay, the condition is AB is equal to lambda AC. So this vector is equal to lambda of this, that is minus 2i plus j plus 3k is equal to lambda into 8i minus 4j plus 12k. Okay, can I take 4 common? Yes, right. That will be minus 2i plus j plus 3k. Let me take minus 4 common from this. This becomes minus 2i plus j minus 3k. Is it right? Yes or no? Right? Now check whether all are equal. Minus 2i plus j plus 3k minus 3k. Let us check, is this plus? Minus 13 plus, this is minus 12. These are the basic things which you will always get confused. Okay. Now if you observe, minus 2i plus j plus 3k minus 2i plus j plus 3k got cancelled. It is 1 is equal to minus 4 lambda, lambda is equal to minus 1 by 4. Clear? Next. Here he gave OA, AB, BC, CD. He is asking us to find OD. How is it? OA, next AB, next BC, next CD. How do we find OD? That is nothing but I have to add all the vectors. Okay. Now see here, OD is equal to OA plus AB plus BC plus CD. Isn't it? Just add all I coordinates here. 1, 4, 5, 7. Next, j coordinates 1, minus 2 plus 2 will get cancelled. 1 plus 1 is 2. Next, 1k, 2k, 0, and I will be left with 3k. Is it fine? Shall we go to the next question? Let's do. Look at the question here. ABCDE is a pentagon. If the sum of AB, AE, BCD, CD, AC is lambda AC, he is asking us to find the value of lambda. Now tell me how a pentagon looks. Pentagon is a polygon with 5 sides A, B, C, D and E. Okay, now let us draw these two. Okay. Now let us draw these two sides. Clear? Now if you observe, why did I draw only these two is, you will get to know. Here the sum of all, what are those all? AB plus AE plus BC plus DC plus ED plus AC is equal to lambda AC. Isn't it? Where is AB? AB, AE, BC, DC and ED. Clear? Fine. Now just observe what is AB plus BC. Let us write these both in one side. Okay. And the next AE and ED in one place. AE, ED. AE, ED. Okay. Still what are left? DC and AC, that equal to lambda AC. Clear? Fine. What is AB plus BC? Tell me. That is AC. What is AE plus ED? That is nothing but AD. How? This is from triangle of vector. If two sides represents two vectors, then the third side represents the sum of the two vectors. Then next, DC plus AC. Okay. Now what is AD plus DC? AD plus DC is nothing but again AC. Okay. Now how many ACs do I get? 3 AC is equal to lambda AC. Therefore lambda is equal to 3. Clear? Fine. Next, A and B are two vectors which are collinear at sums. Collinear means again this vector is equal to lambda into that vector, some constant. Okay, that is A bar is equal to TB bar. What is A? 2i plus 5j plus k is equal to T into 4i plus mj plus nk. Clear? Now just multiply. 2 is equal to 40 right? Next, 5 is equal to Tm, 1 is equal to Tn. Now here 2 ones are 2 twos are, the value of T is 1 by 2. Just let us substitute it here. 5 is equal to 1 by 2 m, m is equal to 10. The same substitute it here. 1 is equal to 1 by 2 n, n is equal to 2. Is it right? We got the values for m and directly. Clear? These are basics of vectors, and we did few problems of addition of vectors. Clear? Fine. This is for today. Let us meet in the next session with the more problems of addition of vectors. Thank you.